So I'm here to talk about the realities of building a modern AI data stack, not a modern data stack. So I'm going to define that. What is a modern AI data stack? We're going to talk about how we get from the modern data stack to that. So I might rant a little bit. But let's start there. Let's start by talking about the modern data stack. So I did what everybody does. Start with ChatGPT, right? So ChatGPT says a modern data stack is an integrated ecosystem of tools and technologies designed to collect, store, process, analyze, and visualize data efficiently and at scale. That is a very, very dense sentence. I did say in one sentence, so we'll give a break. But really what that says to me, I like to put things in pictures, is that we're starting with collecting data, then storing it, then we're processing it. So that's sort of like the ETL piece. And then we're analyzing it to get visualizations out, right? It is a pipeline. And so the name of the game here, and this is what the name of the game has always been, is to get the data to a point where you can make decisions and make your business better with data. Very straightforward and simple, right? So the modern data stack, I'm assuming everyone here is familiar with it. Perhaps you heard it's dead. Perhaps you think it's still alive, unclear. But it's about BI tools. It's about ML. It's about tools, though, and technologies. And it's very vendor-driven. Good reason. In some ways, it's a architecture diagram. And I tried to simplify it here, but essentially, the focus is on structured data. So when I say structured data in this talk, I mean things that are tabular or can be represented in a database. The volume's fairly manageable, typically. And we've been doing this forever, right? So you have some collection where you can bring data into the cloud, or maybe it's already in the cloud, and then you're curating it, maybe with a cloud tool. Maybe you're doing that in the cloud data warehouse. Maybe you're doing it before it gets there. And then you've got BI tools, which hopefully are web hosted. And the great thing about this is that you don't have to think about infrastructure. You don't have to manage these tools, really. In reality, you do. But as Lindsay said in her talk about cost earlier, which you didn't see, you should see it, the modern data stack costs a lot, and it's designed to make money, right? So you have to think about that. And we've been doing this forever. Now, I've been doing this for 20-something years, and I'd like to point out that this looks incredibly familiar. For those of you who can take a little journey back in time with me, we used to have this thing called the mainframe. In fact, we still do. And we used to take mainframe data and use things like Informatica or Ab Initio, data stage, and we would transform the data and land it in something like Teradata, which was very exciting. We had this thing called the data warehouse. And people would have EDWs and DWHs and all these exciting things. And then in the end, everybody used Excel, which is probably still true today. So this is more of a legacy data stack. So this is the part where I get a little ranty. They're the same thing, right? It's the same picture. It's just cloud and SaaS and composable to a degree where it wasn't before. So to me, I've been saying this for years, but I don't think the modern data stack is very interesting. I think it's actually just the same thing, and it doesn't improve on the life cycle of data the way it should. Projects are still failing, and now, guess what just entered the chat? AI. So we're going to complicate things more. So just to reiterate that, and this is something I wrote in an article a couple years ago, the modern data stack is just a cloud SaaS composable version of the legacy data stack, and a true modern data stack needs to really focus on the path from data to the value and not about the tools in between, right? We're replicating data too much. We've got too much latency. We need to be more modern. So we're at an inflection point now. There have been a few of these over the past few decades, and one of the keynotes spoke about this very, very eloquently. But I think we're at a significant inflection point right now with the onset of the era of AI. We've got personal computers. You can go back and say the Industrial Revolution started it all. But we've got personal computers, we've got the cloud, we've got mobile computing. So I think that this is the perfect time to take this opportunity to figure out how to really, truly improve our relationship with data and how we get value out of data. So what should a true modern AI data stack look like? Let's ask ChatGPT, right? So this answer is actually very similar. It says a modern AI data stack typically comprises advanced machine learning frameworks, scalable data processing platforms, robust data infrastructure, and comprehensive analytics tools integrated into a cohesive ecosystem for collecting, storing, processing, analyzing, and leveraging data to train and deploy AI models effectively. Once again, we're talking about a pipeline, right? Except this time we've got AI at the end. That's easy, right? You just add another box. It's so simple. And it is the same thing, more or less, but you'll notice that instead of focusing on technologies, this is more about frameworks. It uses the word ecosystem again. It's about infrastructure and the entire system for data. And obviously there's AI-specific wording as well, but the interesting thing is that we're still talking about a pipeline. And now we have a much loftier goal. So the AI box at the end is actually really deceiving. That's much harder than it looks, obviously. AI pipelines are incredibly complicated. The scale of data at each step along the way varies wildly. At the very beginning, you might have tens of petabytes of data, and at the very end, you might have that as well, but along the way, you're reducing the amount of data, but then you're also generating data. This is generative AI, right? And then on top of that, you have different types of compute. You have GPUs and CPUs at each step of the way. And guess what the biggest challenge still is today? Data engineering. So the data engineering has always been the biggest challenge, and I truly believe it still is. And not everyone is training foundational models. Not everyone is writing their own LLMs, so this might be a little less complex. And you can simplify this with things like AI cloud service providers that'll provide you with storage and GPUs, or there's other emerging tech you can use, and you can just fine-tune existing models. But one thing to note is that this is really complicated, and the modern data stack does not work for this, right? Like there's no place in here for the modern data stack. So thus far, the modern data stack has focused almost entirely on structured data and really getting us to the point where visualization and analytics are something that we can get almost out of the box, right? And I think that's great, but I think the modern data stack has reached its limits. I'm not going to go so far as to say it's dead, because I think there are certain cases in which it makes a lot of sense, and I'll get into that in a bit. But the modern AI data stack needs to handle not just structured data, but structured, semi-structured, and unstructured data. So how different are these two things, structured and unstructured data? Well, structured data, it turns out, is about 5% of the entire body of data that we have to work with, whereas unstructured data is the other 95%. So we've been not ignoring it, but we've not been activating it in the same way that we can. And so this is why AI is really cool, because now we'll be able to actually use all of our data. And so that brings up really interesting questions, though, because the things we've built for this smaller scale won't work for the larger scale. So we need to think about things like infrastructure, monitoring, recoverability, and checkpointing in a way that we've never thought about them before. The way you do exploratory work and development at this scale is going to be different. Everything gets more complex. So the point I want to make is that what got you here to modern data stack, if that's where you are, won't get you to the next step. And it certainly won't get you beyond whatever the next step is. I don't know what that is, but we'll find out probably at Data Council next year. So here I've got sort of a comparison between BI and AI, and I know those are fuzzy terms. For the most part, when I'm saying BI here, what I'm meaning is, focus on structured data, things like analytics and machine learning that we've been doing for the last 10, 15 years, maybe even longer. And then basically what we've done until today. And then when I say AI, I mean deep learning, LLMs, Gen AI, that kind of thing. So the data, again, AI, any type of data can be involved in AI. The volumes that you're talking about, instead of talking about gigs and terabytes, now you're talking about petabytes and exabytes. Like, good luck putting an exabyte of data into Snowflake, right? It'd be very expensive. And then from a complexity standpoint, the complexity, once you add in all of your data, is going to go through the roof, which is great because that also means the value can be higher. But you need to really think about that because we don't even know what we can do with AI yet, right? Like I've talked to a lot of our customers who, their board is saying we need to do AI. To do what? They don't even know. And so they're like, oh, we'll put a chat bot in and fire our customer support people. But, I think in reality, there is so much we can do with AI that we haven't even scratched the surface yet. And I see people nodding, don't fire your customer support people. And then there's questions about real-time processing, right? Like, I don't know if you guys saw the Fig Jam talk, but I don't want to wait 40 seconds for something to appear on my screen. I want stuff now. I'm very impatient. And then you have to think about your consumption pattern. So your consumption pattern has typically been human first with BI, but with AI, it could be machine first, human second. So you have to sort of think that through. Governance, who even knows, right? There's regulations coming out every day, and they're different, for the EU, for the US, for elsewhere. So, and a lot of people fear AI. When I told my parents I was working on AI, they were like, what? They don't know anything about computers. It's fine. I think they pictured robots. So that's cool. Makes me look cooler. And then in the bottom, we have probably what's to me, the most interesting piece, which is the infrastructure. So the modern data stack's all about cloud. It's elastic, it's SaaS, it's easy. You can spin up a modern data stack in like hours. For AI, good luck with that. You can probably do that if you use an AI cloud service provider, but maybe not that quickly. But we have all this advanced compute and specialized hardware that we need to start thinking about. And so data folks need to start thinking about infrastructure, and then infrastructure folks need to start thinking about data, which has been really fun and challenging. That's what I do for my job. So nothing I've mentioned here involves the key tenets of the modern data stack, right? But the inherent goal still remains that we're going to use our data and try to get business value out, whether that's BI, AI, selling data products, whatever we're doing. So if you consider all these things, in the end, AI really is a different paradigm, and we need to rethink everything. So we need to think the complexity of our pipelines. We've been copying data around, we've been moving data into the cloud and back out. Every time you move your data, you're adding latency, you're adding risk, you're reducing resiliency. It's just a challenge. And so that's been a challenge, and those are the tools that have been designed for BI. The performance requirements are completely different. You have scalability challenges. I mean, I don't know if you have looked at this, but like an AI model, GPT, is something like 700 gigs, right? That's a big model. So you're going to have to think about these things. And then, as I said before, you have to think about future proofing, because who knows what's next, right? And who knows where we're going to be in 5 years. So you got to sort of think about building something that will scale out. And then finally, cost. Cost is always a fun one. So basically what I'm saying is that AI is making the modern data stack not really effective anymore. I love a meme. See, I told you I'd try to keep you awake. All right, so bottom line though is that things are getting really complicated, and we've got to keep doing what we were doing in the same time. Like your execs are still gonna want their dashboards. And I'm telling you, throw all that away? No, you can't do that. So we've got to keep doing what we were doing and think about building out something that will be scalable, performant, cost efficient, all those good things. So one thing I like to think about a lot is data maturity. So let's step back for a minute and think through that. So data maturity to me takes on several different dimensions. One is that a data immature organization, and a lot of organizations are not what I would call data mature, and that's okay because small organizations, startups, don't necessarily need to be. But size and maturity don't always go together, so you have to think about that. But typically it's a not data mature organization would have a small data volume, not very complex data. You'd have a small team handling that. You might not have a chief data officer. You might be a data team of one. You would probably have centralized data ownership by that team. Data would be essentially treated like a byproduct, right? Like it would be thrown over the fence to that team. And it would be governed by that team and maybe a risk officer type person, a GRC. And then on top of that, you would have a siloed data infrastructure. You would have like a person or a team with their own infrastructure that's separate from everything else. Probably sounds familiar, especially from startups. I know I've worked in a quite a few organizations like that where I was the only person. So the other end of the spectrum is a data mature organization. And what I would say is that they probably have large data volumes. That's more complex. The data itself is more complex. And therefore, you have a large data organization to help handle those data volumes. Hopefully, you would have a domain-driven data ownership. And what I mean by that is that your data creators are being held responsible for the data that they are creating. They are accountable for that data. You would also treat data as a first-class citizen of the business. It would be a product. You would also have a federated governance model where the domain owns some of the governance, maybe access control and GDPR and other regulations. And then there's other things that are handled at the organizational level. And then last, you might have some sort of IT department that's handling your self-service data infrastructure. Does that sound familiar to anyone? Does that sound like something? Data mesh, yeah, that's data mesh. So I didn't just add data mesh and data products to the description of this talk because I like buzzwords, which, I kind of do. But I genuinely think a data management strategy is going to be paramount in the age of AI, right? Like, it was already incredibly important, and it's something that people have been thinking about for a long time, especially in large enterprises. It's going to be that much more important with AI, though, because we're going to have auditability of these models, and we're going to have to understand where the training data came from, where all the labels came from, where everything came from. So what this says to me is that a less mature solution would be something like the modern data stack. A more mature solution would be something that's much more forward-thinking, like a data mesh or a data fabric, if you prefer. Let's see. So just to reiterate, I think data management is incredibly critical as you mature your data organization. And if you're doing AI, you are maturing your data organization, whether you like it or not. So you need well-curated, well-documented data. You need to model it. You need to understand what is where. You need lineage. You need all these good things that all of these talks have been talking about, which is great. You need to govern your data. You need PII management, all that good stuff. That's why I've stayed away from healthcare my whole life, because I'm terrified of HIPAA. Healthcare data, to be clear. I go to the doctor. There's also a culture of data literacy that comes with this, and that goes with the domain ownership. That's probably the hardest part of data mesh, is the people part, right? Hardest part of anything. And then you need a scalable infrastructure, because remember, we went from 5% to 100% of your data, and now we're talking about creating even more data with Gen AI. So data products, I believe, are the key to helping handle that, whether you're doing a full data mesh or not. And I'd like you all to appreciate, I built my first Jiffy. I'm very proud of it. Hopefully that helps wake you up. That was a good movie. Yeah, so I think, AI engineers in the future, I think focusing on things like data products is going to be really important to them. So, all right. So moving forward, let's talk about the modern AI data stack and what that looks like. So I'm going to deep dive into each of these. We've got scalability, performance, cost, accessibility, and simplicity. All right, and I'm doing okay on time, so I have time for this. All right. So scalability, again, we're getting to the point where we're still talking about petabytes, but exabytes are coming. We start to have customers. I've got some customers who have exabytes of data. And what comes after exa? Is it yada or zeta? Zeta, I think. I think it's zettabytes comes next. But that's what's going to, in 5 years, we're going to be talking about exabytes and zettabytes. And so we need things that are scalable. You can't have an infrastructure where your costs exponentially go up, right, with increase of volume of data. And that's not just for basic data storage, not just data lake, but also database solutions need to be scalable. Okay, whether it's a data warehouse or a database, you need to be able to handle that volume of structured data in your database. You also need to be able to accommodate large models. I alluded to this earlier, but some of these models are almost a terabyte themselves. They don't fit into memory. They have to be parallelized to even fit on disk. Things like, distributed and parallel are paramount and are non-negotiables at this point. So you have to think through all of that. And then while you're doing that, you also have to keep in mind that everything needs to be upgraded and maintained. So you got to keep going. So when you're thinking about scalability, these are some of the things you need to focus on. Then we talk about performance. And I was at GTC last week, the NVIDIA conference, and they unveiled the Blackwell chip, and they're talking about performance, and everything's awesome. But, there's a few different axes you can think about performance. There's real-time ingest, processing on the consumption, on the storage side, and then there's integration with other systems. There's curation, there's consumption. I would like to say that the days of waiting a day for your data to update are over. I don't think we're there yet. I really would like to get there, though. I don't think you should have to wait around a day for your data to be fresh. But that said, you also need to think about query response times in your different architectures. So as far as scalability goes, I don't know a lot of enterprise scale companies that are just on-prem or just in the cloud. Most of them have some sort of hybrid architecture, and I think that's something we need to embrace. But then that means you also need to think about how your queries are responding at each of those places. And then you get into the chips themselves, so CPUs, GPUs, DPUs, whatever's next from NVIDIA and others. Some people make their own, we've got lots of different things going on there. And then once you get into that, GPUs actually have a pretty high failure rate, so you need to start thinking about things like checkpointing and recovering. I actually wrote a blog about this because checkpointing is all math. Super fun, if you like that kind of thing. But it's all about if you've got this massive model running for 3 days and it fails on the third day, you don't have to start over again. So checkpointing and recovery becomes a really fun math problem. So that all said, then of course there's cost, which is super fun. So there's obviously the infrastructure costs, right? So whether this is cloud, on-prem, out at the edge collecting data, there's cost for all of this, and none of it's free. I used to say storage was cheap back in the day. I don't know why I said that. It was naive, I guess. But we also, like I said, have hybrid architectures, and we have to live with that. I think, it's nice when you're small and you can be all in AWS or something, but I think once you get to a certain size, that's just not feasible anymore. Now that we're talking about LLMs and we're talking about a scale that we've never seen before, we have to reconsider architectures. And then we need to consider the compute resource evolution. So like I said, I was at GTC and they unveiled a new chip, but they unveiled a lot of other processor functionality as well. And so we need to be prepared for whatever comes next. Somebody was talking about graphene and how it's the material of the future, and I went and Googled it. It looks super cool. So maybe that's what everything will run on. And then the consumption model. I mean, there's amazing tools out there for both BI and AI, but we need to think about how all of this performs and is 40 seconds okay for a response time, or do people expect things instantaneously? Spoiler alert, it's the latter. And then, of course, there's organizational costs, which are non-trivial, so got to think about that. All right, a couple more. Accessibility, we always think about this as data security and privacy. This should actually be first. It's the only thing that really matters if you think about it. But then there's risk management, regulatory compliance, high availability, failover, BCDR. These are all things that when you're building out these systems, you have to consider that when you had the modern data stack, were largely considered for you. You would just download Snowflake's BCDR statement, give it to your chief risk officer, and you're done for the day. But now you actually have to think about designing this, and it's different for BI and AI. Same for access control and governance. Luckily, this is something that it's not figured out, but there's a lot of models out there. There's a lot of good tools out there, so hopefully it's less of a lift. And then data catalogs, which are some really amazing things out there, but it's not just structured data anymore. It's unstructured data. So you have to think like a storage admin. You have to be like, who accessed this unstructured file and things like that, which is fun. All right, and then the last thing I want to talk about is simplicity, or efficiency, if you will. I said fewer pipelines is less risk, more resiliency, less fragility, less latency, more cost efficiency, and that is absolutely true. Every time you create a copy of your data, you're adding in all of those bad things, right? So fewer copies is better. So start to think about how you can actually build a very streamlined and well-architected data ecosystem. Data products, again, I'm just gonna keep harping on that, sorry. Data products are a key, right? And just having like well-documented, easily discoverable, accessible, secure data products that people can access so they don't have to go build their own pipelines. That's really going to be paramount going forward. Again, no more replication. I mean, obviously we're going to replicate data, but at the volumes we're talking about now, every replication is really significant in a way that it might not have been before. We also need to think about real-time versus batch. This is something that, maybe real-time is necessary. I want my ChatGPT response right away. Maybe it's not. We'll see. It depends on your use case. And lastly, simplicity is going to enable everything else. And the more efficient your pipelines are and your data ecosystem is, the more scalable it will be, the less it will cost, hopefully, the more performant it will be, and the more accessible it'll be. Okay? So now I've painted this beautiful, perfect picture. What do we want? The perfect, future-proof, modern AI data stack, right? Easy. You want it yesterday or today? Which one? So simple. Well, that's great. Just go here and pick it out, right? This is last year's diagram. I haven't seen this year's diagram. I don't know if it's out yet, but it's a lot, the Mad data diagram. So this is our data landscape last year, and I guarantee it's very different this year. But these tools were not necessarily built for that. This is composable to a fault. It is composable to the point where it is just overwhelming. And again, it's designed for cost, right? It's going to cost you a lot to pick one thing from each section and put together the perfect data stack. Not that that's how it happens, but I think that we're not there yet. And I think that these are all the things that you need to think about when you're building an AI data stack. But I'm very excited about what this will look like for 2024 and 2025. Usually it comes out in February, so maybe I missed it. I don't know if anyone's seen it yet. So, is that overwhelming? No? Everybody ready to go build? So, I get overwhelmed when I think about this, and I think about it a lot because my company, I don't know if you know Bass Data, we make a all-flash data lake. We have a database, a data engine, catalog for all your data, and we think through these things. And my job is mostly thinking about how we can streamline data pipelines for AI. And we are the backbone of a lot of AI ecosystems at the largest scales, and also a lot of the AI cloud service providers like CoreWeave and Lambda Labs. So, we know what we're talking about when we do this. It is challenging though. And data management is not something that people think about nearly enough. So I'm going to leave you with 4 key takeaways. I think these are important, and hopefully this will help get you started. Number 1 is to focus on data's path to value. And the key word there is value. So what is the value? That's for your business to decide, because each business is going to have unique value there. And I think focusing on that data's path to value as opposed to the tooling that gets it there is going to keep your eye on the prize in a way that's incredibly important. Consider hybrid architectures. Maybe you've been a GCP shop for a really long time, but now you're bringing in incredible amounts of data. At least consider what repatriating would look like. And when I say this, it's because a lot of our customers have spent years and years on cloud journeys. And now they're giving up because now they're doing AI and they're trying to, solve for this problem with a lot more data. And so they're starting to go back to on-prem. And there's also these other solutions like cloud service providers focused on AI. Like I said, use data products. It's going to help you, I promise. And then start small and keep it simple. I mean, this is always the advice, right? But I think there's really something to it. Find MVPs and don't boil the ocean from the start, but really think about where you're going and how you can build something to iterate upon. So that's it. Thank you very much.